Okay, so here are the answers to the study guide for sections 1 through 4 on chapter 7. Go ahead and pause here and check your answers. I'll work through them here in just a second. Example 1 here. Remember that anything to the 0 power is 1. It doesn't matter what's inside our parentheses. So because we have a 0 exponent, this is just going to equal 1. With negative exponents, remember that our negative outside doesn't go with, it stays. It's just like if we had negative 1 times 4 to the negative second. So we have a negative outside. To get rid of a negative exponent, we move the whole factor to the denominator and change our exponent to be positive. So instead of having negative 2 as our exponent, in the denominator we have a positive 2. So we move it to the denominator and make our exponent positive. Same thing in number 3 here. In number 2, we could have simplified this further as negative 1 over 16. 4 squared is 4 times 4, 16. The multiple choice answers didn't have that as an option. They stopped here. But on your quiz, we would want to go further, just like we're going to do in number 3. So in number 3, again, we have a negative exponent. So to make it positive, we move that whole factor to the denominator, and we change our exponent to the positive, to its opposite. So instead of being negative 2, it's positive 2. And we put a 1 in the numerator when we don't have anything else. Negative 3 times negative 3 is what negative 3 squared equals. Okay, we take its base times itself twice, which is going to give us 1 over 2 negatives, make a positive 9. 1/9. Number 4 here, we only move the things that have negative exponents. So g is the only thing with a negative exponent. So that we're going to move to the denominator, change that exponent to positive. But the 8 and the d to the 6th power, we didn't have to move. Those already had positive exponents. So we keep them exactly where they're at. Again, we keep them where they're at unless they have a negative exponent. If they have a negative exponent, we move it to the opposite part of the fraction and change our exponent to be positive. We don't change the sign of our numbers, just change those exponents. Number 5, same idea here. We have a negative exponent, and to get rid of a negative exponent, we move it to the opposite part of our fraction. So I have a to the positive 5th power in the numerator. In my denominator, I still have a 1, but I don't need that. Anything divided by 1 is itself. So a to the 5th power. And again, I'm not putting the A, B, C's, and D's answer because those are on that front slide. So if you need to, go back to the beginning, pause it there, and check your answers as you go, or match them up with the letters as we go through here. 6, we keep everything exactly where it is unless it has a negative exponent. So the only thing I'm going to move in this fraction is the a. The 3 stays in the numerator, the b stays in the denominator. The only thing I move is the a. And to get rid of the negative exponent, we move it to the top part of the fraction and change that exponent to be positive. 3a to the positive 9th, and still divided by b. That b doesn't have a negative exponent. It has a 1. Remember, if there's not an exponent, it's a 1. And since it's positive, it stays. Same with our 3. Our 3 stays in the numerator. Number 7, same idea here. I'm going to go ahead and simplify this first before I start plugging in numbers. So my 4 has a positive exponent. It stays in my numerator. My x has that negative 3, so I'm going to put it in the denominator, make it positive. To get rid of a negative exponent, we flip it to the opposite part of our fraction and make it positive. My y is already positive, so that stays in my numerator. Now I'm going to substitute. I have a y, which means I'm going to substitute negative 1 in. Then I have an x, so I'm going to substitute 3. 3 cubed. Negative 1 times negative 1 is what negative 1 cubed is. And 3 times 3 times 3 is what 3 cubed is. Remember, exponents mean repeated multiplication. Here, 4 times negative 1 is negative 4, times negative 1 is positive 4, times negative 1 is negative 4. We have an odd number of negatives, 1, 2, 3. 2 negatives make a positive, but the last one means our answer is going to stay negative. In the denominator, 3 times 3 times 3 is 27, and we get negative 4 over 27. Number 8 here as well, I'm going to simplify first. So all of my negative exponents, I'm going to move to the opposite part of my fraction. 2 goes to the numerator with a positive 2 exponent. X goes to the numerator with a positive 3 exponent. And in my denominator, I keep the y to the 5th because it already has a positive exponent. We only move things if their exponent is negative. That's the only time we flip from top to bottom or bottom to top. Now I can simplify here. 2 squared is 4 x cubed over y to the 5th. We'll plug in our values here. 4 times 2 cubed divided by, when we plug y in, we've got to plug it into parentheses before we take the exponent. We need the whole negative 4 to be to the 5th power. When we multiply here, 4 times 2 cubed is 2 times 2 times 2, which is 8, divided by, it's going to end up being negative because we have 5 negatives. Every 2 make positive, so 1 left. And 4 to the 5th power, okay, 4, exponent key 5 if you're not sure, 1024. 32 over 1024, and this answer is going to be negative. And we can type that in our calculator as a fraction to simplify it. 32 fraction 1024 gives me negative 1 over 32. The other thing we could do is, I know that 4 goes into 1024 256 times. I could take 8 out of that and keep simplifying by 2s or 4s or however you know as well. That would work. Number 9. What is the value of y to the negative 5th power over x to the negative 3rd power? To simplify this here, negative exponents, we move to the opposite part of our fraction. So, in my y's, I'm going to move to the denominator to make my exponent positive. My x's, I move to the numerator and make them positive. Now I can substitute. X is 2 cubed over y is negative 4 to the 5th. 2 cubed is 8. Negative 4 to the 5th power, we just said, negative 1024. And when we simplify this, we're going to get negative 1 over 128. And again, we can simplify that using our fraction key or by dividing by common factors. Number 10. Suppose that the amount of algae in a pond doubles every 4 hours. If the pond initially contains 40 pounds of algae, how much algae will be in the pond after 12 hours? So y equals a times b to the x power. And b is the number that we're multiplying by. A is our initial amount. Our initial amount is 40. The number that we're multiplying by, it says, is doubles. So times 2 to the x power. And that x is split up for every 4 hours. So how much algae will be in the pond after 12 hours? We take that 12 hours and divide by 4 hours to figure out how many times it's doubled, which means 3. It went from 4 hours to 8 hours, 8 hours to 12 hours. Okay, 0 to 4, 4 to 8, 8 to 12, 3 times. So we plug that in for x. 40 times 2 to the 3rd power. which 2 to the third power is 8 times 40 is 320, or you could have typed that in your calculator. And our answer is labeled in pounds. (11) What is each expression written using each base only once? So we're going to keep our answer in terms of base here. In number 11, we're multiplying powers with the same base. Same bases are 8, multiplying, which means we're going to add our exponents. Keep our base, add our exponents. So 8 plus 4 is going to give me 8 to the 12th power. Number 12, same idea. Multiplying powers, same base, so we keep our base, add our exponents. Negative 4 plus 4 is 0, which gives me 7.57 to the 0 power, and we know anything to the 0 power is 1. Negative 5, again, multiplying powers, same base, so we add our exponents. Negative 5 plus 6 gives me negative 5 to the first power, and anything to the first power is just itself, negative 5. Multiplying powers, same base here. Even though we have 3 things, that's okay. We take our bases, combine them into 1, and since we're multiplying, we add our exponents. 10 plus negative 4 plus 7, which gives me 7 to the 13th power. Simplified form here means we're going to simplify it all the way. So in these last 4, we left them with their bases. In these ones, we're going to go ahead and simplify. So the things that we're multiplying that have the same base are the b's, but our 2 and our 5, we're still just going to multiply. We're multiplying all of these factors. So 2 times 5. Powers to the same base means we're going to add our exponents. 2 times 5 is 10, b to the 9th power. 16, same idea, we take 7 times 6, and our x's have the same base, we're multiplying power, same base, we add our exponents, which means we get 42, x to the negative 5th power. In order to have it simplified, we're not going to have any negative exponents. So we're going to have 42 stays. The only thing that has a negative exponent is this x. So the x goes to the denominator and becomes a positive 5 exponent. To get rid of a negative exponent, we move it to the opposite part of our fraction, make it positive. 17 here. I have 2 times 5 as far as my numbers go. My variables, I have x's, 8. Since I'm multiplying, I add my exponents. Y to the 10th. Gives me 10, x to the 13th, y to the 10th. I can only add my exponents if my bases are exactly the same, which means I can only put my x's with my x's. I cannot put them with the y. That base is different. 18. Negative 4 times 2 times 5. I can multiply all of my number parts. My x's, I have 3 plus negative 8. My y's, I have negative 2 plus 5. Negative 4 times 2 times 5 is negative 40. X to the negative 5, y cubed when I combine those exponents. Again, I don't want to have a negative exponent, so I move it to the bottom. My 40 stays. Even though the 40 itself is negative, its exponent is just a 1, which is positive. The only exponent I move is my negative exponent. So my x to the 5th goes to the denominator, becomes positive. My y cubed stays there. I have reached my time limit for recording, so I'm going to stop this one here, and I'll start the next video on number 19.